Assalamu alaikum and welcome to Mathcast with Faria Yusuf. And this lesson is with respect to all the past, not all, but selected past paper questions for trigonometry, solving equations, and identities. This paper is selected from October-November 2015, paper 1, variant 1, and it's question number 4 from the paper. So the question says, show that the equation we have to show that the equation 4 cos theta divided by tan theta plus 15 is equals to 0. This equation can be expressed as 4 sine square theta minus 15 sine theta and a minus 4, which is equals to a 0. So what we can see here is that the equation, which was initially in terms of cosine and tan theta, that should get converted to sine theta in this equation, a quadratic equation having this sine as the trigonometric ratio. So it's 4 cos theta over tan theta plus 15, which is equals to 0. Meaning if I take the LCM, then this becomes 4 cos of theta plus 15 tan of theta divided by tan theta, which shall be equal to 0. So this means if this tan theta here, gets multiplied by 0, then it's 4 cos theta plus 15 tan theta, which shall be equal to a 0 here. Now just keep the objective in mind, that the whole equation shall be expressed in terms of sine theta. So tan theta here can be replaced by sine theta over cos theta and this shall be equal to a 0. So again, if I take the LCM, then this needs to be a cosine theta as the LCM, and then this becomes 4 cos square theta plus 15 sine theta, and this is equal to 0 then. So this means our equation is 4 cos square theta plus 15 sine theta, and this should be equal to 0. Just remember, I have to express the entire equation in terms of sine theta here. It should be a sine square theta, a sine, and the sine theta, and then it should be a constant here. So this means this cos square theta, I can replace this cos square theta by 1 minus sine square theta. Now you can see that we are just applying the identities here. The first identity that I applied was for tan theta, which is equals to sine theta over cos theta, and after that I'm using the identity for cos square theta, which should be equal to 1 minus sine square theta. So solving it further, this is 4 minus 4 sine square theta plus 15 sine theta, which should be equal to 0. Or taking the LCM, taking the negative sign common, let's rearrange it first. It's negative 4 sine square theta plus 15 sine theta and plus 4, which is equals to 0. And if I take this negative sign common, I'll be left with 4 sine square theta minus 15 sine theta and a minus 4, which shall be equal to a 0. So this negative here, when taken to the right side, gets divided, 0 divided by a negative 1. Obviously this needs to get eliminated, and the final answer that I should be having here is 4 sine square theta minus 15 sine theta and a negative 4, which then shall be equal to a 0. So this is what we wanted in the equation, 4 sine square theta minus 15 sine theta and a minus 4, which is equals to 0, and we have obtained the result. Therefore, in the end, I should simply write that it is shown here. So this is how we need to do the first part for this equation. So the second part of the equation says, hence solve the equation 4 over cos theta 4 cos theta divided by tan theta plus 15 equals to 0, and they have given us the domain which is from 0 degrees till 360 degrees. Now we have already solved 4 cos theta divided by tan theta plus 15 equals 0 in the first part and expressed it all in terms of 4 sine square theta minus 15 sine theta minus 4 equals 0. Meaning in this second part, 4 cos theta over tan theta plus 15 can be replaced by 4 sine square theta minus 15 minus 4, and then this shall be equal to a 0. Solving for the second part, we have to solve 4 cos theta over tan theta plus 15, and this is equals to 0, and they have given us the domain which is 0 lesser or equal to theta lesser or equal to 360 degrees, meaning all the angle values, they should be solved for all the four quadrants 0 till 360 degrees here. So I can write 4 cos theta over tan theta as plus 15 as 4 sine square theta minus 15 sine theta and a negative 4, which then shall be equal to a 0. So here I can see that it's a quadratic equation in terms of sign. Therefore, I will be using the substitution for m as sine theta, and therefore m square will be equal to sine square theta. So for simplicity, we have assumed that m equals sine theta. Therefore, the equation becomes 4m square minus 15m minus 4, which is equals to a 0. Now, if I factorize this quadratic equation, I'll be getting the factors as a negative 16m and a positive m and a minus 4, which shall be equal to a 0. Or here I can say it's 4m common. I'll be left with m minus 4, and then it's a plus 1 common. I'll be left with m minus 4, and this is equals to 0. So this is m minus 4 times 4m plus 1, which is equals to 0. So m equals 4, or 4m plus 1, this shall be equal to a 0. So these are the two equations in terms of m. And from here, I can also say that this m is equals to a negative 1 by 4. M we have assumed as a sine theta. So now I can replace m with a sine theta, and I can say it's a sine theta which is equals to 4, or sine theta here which is equals to negative 4. Now, for the first part where it says that sine theta shall be equal to 4, we know that all the sine theta values and the cosine theta values, they have to be in the range of negative 1 and 1. And then if they are saying now that sine theta equals to 4, now I should say that this is not possible for the fact that sine theta has to be in the range of negative 1 till 1 here. Therefore, now solving sine theta equals negative 1 by 4, we know the 4 steps. Number 1, locate the quadrant. So I have to locate the quadrant so that my sine theta is a negative, and we know that the sine theta needs to be negative in the third quadrant and then in the fourth quadrant here. Our domain is from 0 degrees lesser or equal to theta, which is lesser or equal to 360 degrees. Therefore, this is a 0, 90, 180, 270, and a 360 degrees. So I can see here that the two rotation values, the angle values, the theta values, they are in the range of 180 till 270 or 270 till 360 degrees. So now find the basic angle. For basic angle, I should say it's sine inverse 1 by 4, or a 0.25. So sine inverse 0.25 then shall be equal to, so the basic angle here comes out to be a 14.48 degrees. So this angle here, this is a 14.48, and on the other side also this is a 14.48. So to get the general angles, the theta angles, I should say that this theta value is equals to 180 plus 14.5 degrees. I'm taking it up to one decimal place. And then for the second rotation, it should be 360 degrees minus 14.5 degrees here. So the theta values here are going to be 194.5 degrees. So the two theta values are equal to 194.5 degrees and 345.5 degrees, and this then shall be the answer for the two theta values that we should be having here in the domain of 0 to 360 degrees. So this is how the first question gets solved here. So the second question has been taken from Winter 2016, Paper 1, Variant 1. And the question says, it's question 6 in the paper, and it says, show that cos of cos to the power 4x, there is an identity. It should be written as 1 minus 2 sine square x plus sine to the power 4x. So it's just a 1 mark question, and to start working on it, cos to the power 4x, I can write it as cos square x to the power square, and this we need to prove as 1 minus 2 sine square x plus sine to the power 4x. So solving the left hand side, cos square x, now again I need everything in terms of sine. That means I should be replacing sine square x by 1 minus sine square x the whole square, and again it's the identity for a minus b the whole square, which is equals to a square minus 2ab and a plus b square. Therefore here 1 minus sine square x the whole square can be written as 1 minus 2 sine square x and a plus sine square x the whole square. So that means it's 1 minus 2 sine square x plus sine to the power 4x, and this is what we had to show. Therefore now I can say the left hand side is equal to the right hand side, and we have shown the identity here. Second part, hence or otherwise solve the equation 8 sine to the power 4x plus cos of 4x is equals to 2 cos square x for 0 to 360 degrees. So let's start solving this question also. So to solve 8 sine to the power 4x plus cos to the power 4x is equals to 2 cos square x, I know here that this cos 4x, we have already solved this in part 1. Therefore now I can say that this cos of 4x can be replaced with 1 minus 2 sine square x and plus sine to the power 4x, and this then should be equal to 2 cos square x. So again in place of cos square x I am going to write 1 minus sine square x. The reason that I am replacing cos square x by sine square x is that if we need to solve the equation, then the entire equation needs to be in the form of one trigonometric ratio so that it can be solved easily. So here I can see that the entire equation now is in terms of sine. Therefore, I should be able to solve it easily then. So 8 sine to the power 4x plus sine to the power 4x, that can be written as 9 sine to the power 4x, and then I have a plus 1 minus 2 sine square x, and this then is equals to 2 minus 2 sine square x here. So solving the equation, it's 9 sine to the power 4x minus 2 sine square x. In fact, here I can see that we have a negative 2 sine square x and a negative 2 sine square x on both the sides. Therefore, both of them, they can get eliminated, as if I take negative 2 sine square x on the left side, it becomes a positive. So negative 2 sine square x, positive 2 sine square x, that will give you the answer as a 0. So just to save time, I have eliminated the 2 over here, and after that I can say that now I should be left here with 2 minus 1, or I can say that this equation becomes 9 sine to the power 4x, which is equals to 1, or I can say it's sine to the power 4x, which is equals to 1 over 9. So to solve the equation, I should first I need to solve for the power, which is a 4 over here. So to solve the power, I will be taking the fourth root of 1 by 9. So doing that, this 4 gets eliminated again, and here you can see that I am left with sine x, which is equals to 1 by 9 to the power 1 by 4. So 1 by 9 to the power 1 by 4, this means I should be having here the sine of x will be equal to positive negative 1 by 9 to the power 1 by 4. I'm taking the positive negative sign because I can see that the nth root that I have taken is an even power. So whenever we have an even power, the ratio has to have both the signs plus and minus, positive and negative. So this means that if my sin x is positive, then it should be present in the first quadrant and in the second quadrant. And then if it's a negative, then it should be present in the third quadrant and in the fourth quadrant. So we shall be locating all the four angles, rotations in the first quadrant, second quadrant, third quadrant, and then it's the fourth quadrant. Next step, find the basic angle. So basic angle then will be equal to sine inverse 1 by 9 to the power 1 by 4. This gives me the basic angle, which is a 35.3 degrees. After finding the basic angles, we know that the basic angle has to be taken with respect to the x-axis. So the first basic angle is in the first quadrant, lying here. Second one over here. The third one is 35.3 here, and the fourth one is 35.3 along this x-axis. Finally, find the general angle, which is x, meaning the complete rotation. So for the first line of rotation, I can see it's just a 35.3. For the second line of rotation, I can say this is the second line of rotation. I can say it's a 180 minus 35.3. Third line of rotation starting from 0, and we shall be going up till this line here. Up till this line, I can say it's a little ahead of 180, so I will be saying it's 180 plus 35.3 degrees, 180 plus 35.3 degrees. And then finally, for this angle of rotation, it's a little behind 360 degrees. So starting from 0 up till the line, I shall say it's a 360 minus 35.3. So general angles then will be equal to 35.3 degrees, 144.7 degrees, 215.3 degrees, and 324.7 degrees here. So this is then going to be the solution for this question. And let's move to the next question then. So the third question is taken from summer year 20 and paper 1 variant 3, and it's question number 7 in the paper. And the question says, show that tan theta over 1 plus cos theta plus tan theta over 1 minus cos theta identity. That means it should be simplified so that it equals to 2 over sine theta cos theta. So to prove the identity, I will start working from the left hand side. So with respect to the left hand side, I have tan theta divided by 1 plus cos theta and a plus tan theta divided by 1 minus cos theta. And I have to show that this, when solved, should be equal to 2 over sine theta cos theta. So one thing that I'm going to do here is I'm going to take the tan theta common, so that I will be left here with 1 over 1 plus cos theta and 1 over 1 minus cos theta. So tan theta can be replaced by sine theta over cos theta, and for the bracket I shall be taking the LCM, and for the LCM I should say it's a 1 plus cos theta and 1 minus cos theta, and first term will get multiplied by 1 minus cos theta plus 1 plus cos theta. Here again, I will be using the algebraic identity, which says it is a plus b and a minus b. This can be written as a square minus b square, which means 1 plus cos theta and 1 minus cos theta can be written as 1 square, which is a 1 minus cos square theta. So what I see here is that this cos theta, it gets simplified, and if this gets simplified, then here I'm left with the sine theta over cos theta times 1 plus 1 2 divided by 1 minus cos square theta. Now I will be using the first identity, which says 1 minus cos square theta equals a sine square theta. So it's sine theta over cos theta, which should get multiplied by 2, and in place of 1 minus cos square theta, I will be writing a sine square theta. The sine square theta and sine theta here, they get simplified, and now I will be left with just 2 over sine theta and cos theta. And this is what the question was asking us about. The question said, prove this identity so that it gets simplified to 2 over sine theta cos theta, and we can see that we are getting the answer as 2 over sine theta cos theta. Therefore now I can say that my left hand side is equal to the right hand side, and we have proved or shown both the sides here. Second part of the question. Second part of the same question, it says, hence solve the equation tan theta over 1 plus cos theta plus tan theta over 1 minus cos theta equals to 6 over tan theta, and we have to solve it for 0 lesser or equal to theta, which is lesser or equal to 180 degrees. Now in the first part, we have shown that tan theta over 1 plus cos theta plus tan theta over 1 minus cos theta was equal to 2 over sine theta cos theta. So using the identity from the first part of the question, I am just going to write this as 2 over sine theta cos theta, and this then shall be equal to 6 over tan theta. So simplifying tan theta divided by sine theta over cos theta, I can see I am having all the three trigonometric ratios here, and for solving an equation we should be having the trigonometric equation in just one form of trigonometry. Therefore here I will be using the identity for tan theta, which is a sine theta over cos theta. This is the replacement for tan theta, and then we already have a sine theta and a cos theta here, and this then shall be equal to a 3. The sine theta here, this gets simplified, and I can say that I am now left here with 1 over cos square theta, which is equals to a 3, or in other words I can say it's cos square theta, which is equals to a 1 by 3, or so cos of theta then will be equal to plus minus square root of 1 by 3. Plus minus, because we know whenever we have to take square root on both the sides, then we have to have a plus and a minus sign here. So with respect to the plus and minus, with respect to the plus and minus and the given domain, which was from 0 degrees lesser or equal to theta, lesser or equal to 180 degrees, I have the quadrant which is going to be positive for cosine in the first quadrant, and then negative for cosine in the second quadrant. So this is up till 0, 90 and 180 degrees. That means the third and the fourth quadrant do not lie in the given domain. So it's just the first and the second quadrant. First quadrant cosine positive, second quadrant cosine negative here. So next step will be to find the basic angle. So to find the basic angle, it's equal to cos of inverse square root of 1 by 3, which gives me the basic angle as 54.7. So these two here, these are the basic angles, and then the general angles. The first angle is 54.7 and the second one shall be 180 minus 54.7, and theta then will be equal to 54.7 and 125.3 degrees, which is going to be the final answer to this question. So the next question is taken from Summer 21, and it's paper 1 variant 1 question 7 part A, and the question says prove the identity 1 minus 2 sine square theta divided by 1 minus sine square theta. The left hand side, it should be equal to 1 minus tan square theta. So there are few identities here that I shall be using, and with respect to the few identities, first one is that I can see here there is a 2. That means this 2 needs to get simplified so that you should be getting just a tan square theta. And then tan theta is equals to sine theta over cos theta. So let's first write down the identities that we shall be using. Number 1, it's sine square theta plus cos square theta, which is equals to a 1. So there are cases where 1 can be replaced by a sine square theta plus cos square theta. Then in the denominator, I can see a 1 minus sine square theta, and from here I can see that 1 minus sine square theta is a cos square theta, and also it's tan theta, which is equals to sine theta over cos theta. Substituting this one by sine square theta plus cos square theta minus 2 tan square theta, this should then get divided by 1 minus sine square theta, for which we are saying it should be a cos square theta. So here I will be left with a cos square theta minus sine square theta minus 2 sine square theta. That would give me a negative sine square theta divided by cos square theta. So I can divide each and every term by cos square theta. So cos square theta divided by cos square theta, and then I can say it's a negative sine square theta divided by cos square theta. So cos square theta over cos square theta, this gives me a 1, and sine theta over cos theta. Sine theta over cos theta, this equals a tan theta. Substituting tan theta as a squared value, because I can see that sine and cosine, they are both the squared values here. So I can simply say that this is going to be a 1 minus tan square theta, and this is what the question asked us to show. Therefore, now I can say it's left hand side, which is equals to the right hand side, and the identity has been proved here. So solving the second part of the question, it says, hence solve the equation. Hence solve the equation, meaning I should be using the results from part A. So hence solve the equation 1 minus 2 sine square theta divided by 1 minus sine square theta equals. So I have to solve the equation. So it's equal to 2 tan to the power 4 theta for 0 till 180 degrees. So what I have done in part A is that I have replaced 1 minus 2 sine square theta over 1 minus sine square theta by 1 minus tan square theta. So if I do that, it's 1 minus 2 sine square theta divided by 1 minus sine square theta. And in this part, they are saying it should be equal to 2 tan to the power 4 theta. So I have already solved for part A. 1 minus 2 sine square theta over 1 minus sine square theta. This was equal to 1 minus tan square theta, which then is equal to 2 tan to the power 4 theta. So I can just arrange the equation so that it becomes 2 tan to the power 4 theta plus tan square theta minus 1, and this then is equals to a 0. So here this equation is having the highest power, which is a 4, then we have a square, and then we have the constant, meaning this actually is my disguised equation. So if this is my disguised equation, I can just assume that m is equals to tan square theta. Therefore, m square will be equal to tan to the power 4 theta. So this means I should be having here 2m square plus m and a minus 1, which is equals to a 0. Solving the equation, I should say, or factorizing the equation, I should say it's 2m square plus 2m minus m and a negative 1, this equals a 0. 2m minus 1 and m plus 1, which then shall be equal to 0. Or in other words, I can say it's m which is equals to a 1 by 2 and m which is equals to a negative 1. So what we know here is that this m was actually equal to tan square theta. So I can replace this m with a tan square theta. And if I do that, I will be having tan square theta, which is equals to 1 by 2, and tan square theta, which is equals to a negative 1. So to get the theta values, I should be taking square root on both the sides. So if I take square root on both the sides, then this tan theta, it becomes a plus minus 1 over square root of 2. And here if I take the square root, then we know that the square root of a negative number is not possible. Then simply I'll say that this solution is not possible. Square root of a negative 1, that's not possible. Therefore, it's not possible to get any theta value for tan square theta, which equals negative 1. So now I have tan theta, which is equals to plus minus 1 over under root 2. That means now we need to follow the usual steps. And the usual steps, first thing is to find the domain. So the given domain is from 0 till 180 degrees. So for 0 till 180 degrees, let's do the working. We have the domain from 0 degrees lesser or equal to theta, which is lesser or equal to 180 degrees. So locating the quadrant, one of the angle needs to be positive and the other needs to be a negative, and we have to consider only the first two quadrant according to the given domain. Therefore, in the first quadrant, our theta is a positive. So this is going to be the angle rotation, and it's negative in the second quadrant. So I should be considering this angle here. So the third and the fourth quadrant, I should not be considering that because they are not included in the given domain. So after locating the quadrant, the next step is to find the basic angle. So the basic angle then is going to be tan inverse 1 over under root 2, and tan inverse 1 over under root 2, that comes out to be 35.26 degrees, meaning here it's a 35.26, and in the second quadrant it's a 35.26 degrees here. So the theta value then is going to be 35.26, and 180 minus 35.26 degrees, or I can say it's the theta, which is equals to 35.3 degrees, and then it's going to be 144.7 degrees here up till 1 decimal place. So this is then going to be the solution for the theta values for the given equation. So the next question is taken from year 21 summer, and it's paper 1 variant 2, and it's question 3 in the paper. So the question says we have to solve the equation. Tan theta plus 2 sine theta divided by tan theta minus 2 sine theta equals 3 for 0 degrees less than theta less than 180 degrees. So to solve the equation here, I have been given the equation, which is tan theta plus 2 sine theta divided by tan theta minus 2 sine theta, which is equals to 1. And we have to solve it for 0 degrees less than theta less than 180 degrees here. So to solve the equation, I can just take the denominator on the other side, so that this becomes 3 times tan theta minus 2 times sine theta. Solving the equation, it's tan theta plus 2 sine theta, which shall be equal to 3 tan theta minus 6 sine theta. Or I can say it's a 2 sine theta plus 6 sine theta, which shall be equal to 3 tan theta minus tan theta. Solving it further, it becomes 8 sine theta, which is equals to a 2 tan theta. So this 2 and 8, I can just simplify them as a 4 sine theta. And tan theta can be replaced by a sine theta over cos theta. So the sine theta here can also get simplified, and then I can say it's a 4 cos theta, which is equals to a 1, or a cos theta equals a 1 by 4. So the given domain is for 0 degrees, less than theta, which is less than 180 degrees. I have cos theta equals 1 by 4. That means I need to locate the quadrant. If I locate the quadrant, then cos theta is positive in the first quadrant, it's positive in the fourth quadrant. But here I need to keep in mind that my domain is just from 0 till 180 degrees. That means I will not be considering again the third quadrant and the fourth quadrant here. So it's just to get the basic angle. So our theta value then comes out to be cos inverse a 1 by 4 or a 0.25, and here I can say that it's the theta, which equals 75.5 degrees. So theta equals 75.5 degrees, and this is going to be the only solution for this question.